Hey there! In this video, we will talk about the pre-training and fine-tuning decoder models, especially the GPT. Let's dive in. Decoder models are effective for tasks that involve sequence generation. For example, in dialogue generation, we pass the dialogue history as context to the model. In text summarization, we pass the document as a context to the model. In general, these decoder models are predicting one token at a time. For example, if you are predicting the token W5, the model receives W4, W3, W2, W1 as input, and it will predict W5. The first GPT model that was introduced had 12 layers with 117 million parameters. This model used a technique called byte pair encoding with 40,000 merges to tokenize words, and it was trained on book corpus with about 7,000 books. Next, it was GPT-2 model. GPT-2 model extended the GPT by scaling to 1.5 billion parameters, and it was trained on a much larger dataset for generating coherent text samples. As you can see in this example here, the text generated by GPT-2, it's kind of acceptable. Next, it was a GPT-3 model, and in context learning. GPT-3 had about 175 billion parameters, and it also introduced context learning. Now, in context learning means that you don't need to train the model in order to learn some new examples. All you need to do is to provide a couple of examples within the context to the model, and the model learns how to map those examples to any new question or example that is coming later. In general, for optimizing these large language models, we need to consider four things. First is prompt engineering. Then it's RAG. Next is fine-tuning. And the fourth one is all of the above. Let's start with retrieval augmented generation, or RAG. RAG enhances the model's capability by incorporating external information into the generation process. By doing so, it improves the factual accuracy and reduces the hallucination of large language models. We first bring a set of series of document or knowledge. We call this a knowledge base. We encode this knowledge base and store them into some database, or it's kind of like a vector database. Then, when the user asks a question from the model, the first thing that we do is to retrieve from that database any knowledge that is similar to the question. Next, we append the question and the knowledge that we retrieved, and we pass that to a large language model. And the model basically generates the result given the user question and given the knowledge that we retrieved from the database. RAG consists of two key components, a retriever and a generator. Retriever is a model responsible for searching through documents or the knowledge source to find a relative or similar document to the question and retrieve those. Generator is responsible for receiving the retrieved documents along with the original query and to generate language or text. First, the query is transformed into embedding. Second, the retriever searches the most relevant documents given the query. Third, the retrieved document and queries are fed into the GPT model. And fourth, the model generates answer using this retrieved knowledge. There are some advantages and challenges for RAG. The advantages are these models improve the factuality of the large language model. They are useful in domain-specific applications like legal or medical. They reduce the need for frequent fine-tuning. However, they also have challenges. The challenges could include dependency on quality of the retrieved documents. Retrieval process can introduce latency and make the model a bit slow. And also, the scalability and efficiency are critical for these real-time applications that might be a bottleneck for application with